Hi, I'm Hana Alfahel, and I'm an applications engineer at Keithley Instruments at Tektronix Company. Today, I'll explain what the double pulse test is and why engineers perform it. I'll show you how to use the double pulse application on a Tektronix Arbitrary function generator AFG31000 to set up your pulses in less than a minute. We will also show measurements on a Tektronix Oscilloscope MSO5 to measure our parameters. We will be doing this test using an ST micro eval board, a Keithley SMU, and a Tektronix IsoView probe, a current probe, and a differential probe. Let's get started.
Efficiency is becoming an extremely important aspect to power converter design. To characterize the efficiency, timing parameters must be accurately measured. The double pulse test provides a way to measure these parameters. The test is done using an inductive load to replicate converter circuit conditions and a power supply to provide voltage to the inductor. The Tektronix AFG31000 outputs pulses to turn on the MOSFET. The first step of the test is a long pulse that establishes current in the inductor. The second step turns off the low side MOSFET, creating a freewheeling current in the diode. The last pulse turns on the low side MOSFET again and allows measurements to be taken. Typical measurements are shown in the figure. The overshoot current from the second pulse is due to the reverse recovery of the diode. The oscilloscope is used to extract the timing and energy loss parameters from the waveforms, such as turn on, turn off, and reverse recovery parameters. One of the challenges of conducting the double pulse test is setting up the pulses. Traditional methods cannot vary individual pulse width or are time-consuming and complicated. The double pulse app provides a quick and a convenient way to program the pulses right on the unit. The software is downloadable and users can create their custom pulses in less than a minute. The app can be found on the home screen and offers a variety of pulse configuration options, including the number of pulses, high and low voltage magnitude, trigger delay, trigger source, and the pulse width settings. Pressing Run outputs the pulses to the device. The Tektronix MSO5 oscilloscope is set up to measure VDS, VGS, and IDS of the MOSFET being tested. The scope captures each of the measured waveforms as well as the pulses from the AFG. The overshoot seen on IDS is due to the reverse recovery properties of the freewheeling diode. To calculate the turn-on and turn-off parameters, we compare the falling edge of the first pulse and the rising edge of the second pulse. The on time is a sum of the time interval between 10% of VGS and 90% of VDS, and the time interval between 90% and 10% of VDS. The off time is a sum of the interval between 90% of VGS and 10% of VDS, and the time interval between 10% and 90% of VDS. Cursors on the scope can be used to retrieve the timing parameters. The energy loss for turn-on time can be calculated using this equation and the integral function on the scope. Also, the turn-off time can be found using the cursor function and energy loss calculated with the integral function. The final measurement is the reverse recovery losses. Reverse recovery occurs when the MOSFET is switched on for the second time. The freewheeling current does not immediately return to zero, but rather the diode conducts in a reverse condition for a short period of time. Using the cursors on the scope, we can measure the time for the recovery current. The power loss can be calculated using this equation and the integral function on the scope.
The double pulse test is a crucial test for design engineers to determine the switching losses of their power devices. The double pulse app on the Tektronix AFG31000 reduces setup time for engineers so they can focus on gathering data and designing more efficient converters. I hope this video has been helpful in understanding the double pulse test. For more information on this topic, please see our app note, which can be found at tech.com with other helpful materials. Thanks for watching.
Find out more at Vicom's website.